what I like to do at this point is I kind of like to share with you a couple stories. And that is, when I first started the internet, my first job on the internet was back in 1991. And I helped run this thing called the internet. Does anyone remember the internet days? Has anyone been on the internet back in the early 90s? Y'all can raise your hands. I can see you now. Okay, I see one. Do I see any more hands? So back in those days, the internet was not very well known, and a lot of people didn't know about it. In fact, it was very informal in many different areas, and a lot of people knew everybody else, and so internet protocols back in those days were also set in a way that there was a lot of trust because everybody knew everybody else within the internet. And unfortunately, some of those protocols today are still not secure. And there's two of them that you use on a day-to-day basis that were built during the days of trust that in today's internet, which is untrustworthy, we're still being reliant on. And that is routing and also DNS. So anyone here a DNS administrator? Okay, I see a couple of hands. Okay, anyone here actually use DNS on a daily basis? I see. Oh, everyone should be raising their hands because everybody uses DNS. DNS is used by everybody. You surf on a website, you're using DNS. You're actually using routing underneath it because when you go to a website, you don't know the IP address and the website that you want to go to. You know the name. And DNS, what it does is it translates the name to the IP address, which your computer needs to communicate with, to talk to the other side to get the content. And before we begin, I want to share with you one more thing. And I really appreciate this, the lightning talk. And I got to share with you that back in the early days of the internet, the backup disaster site was my basement. And the access control was just me. So if I wanted to get something from the disaster recovery site, I had to go to my own basement and take care of it. So that's how things were like in the early days. Certainly not true today. And that was a core internet function from the very beginning. So let's go ahead and talk about some of the core functions routing and DNS. So as I mentioned, there's two critical resources: DNS, which translates names to IP addresses, and IP addresses back to domain names. Why is the latter important? It's used as anti-spam technology. So people use, they find out, hey, this particular IP address is connecting to me. Where is it coming from, and what's the name associated with it? And is it a trustworthy source? And if it's a trustworthy source, you typically mail servers actually say, yeah, I'll accept that mail and I'll go on with it. If it comes from an untrustworthy source, it's usually stopped there in its tracks, and that mail is not received by the mail server. That's one of the best ways of actually stopping spamming. The second one is routing, and it tells you how to route from end site to end site, and that's something that you need to know to get there. And both these things were built in a day, as I mentioned earlier, where everybody knew everybody else, and the internet itself was a closed system in many respects, and security was an afterthought. So, in fact, there was a U.S. government actually put something together in 2002, and it was headed up by this guy named Richard Clark, to say, hey, look, we really need to put security overlays on these protocols. And so Richard Clark headed up this White House experiment, or this task force, and they looked at both how can we secure DNS and how can we secure routing. And what was interesting in that talk is that the protocol for DNS has already been put in place, but it had a lot of work to be done to it yet. It was called DNSSEC. The routing stuff, there was competing camps dealing with it, and to this day, we still don't have a really firm grasp of how to do secure routing. But we do know how to do secure DNS. So that is what I'm going to talk about. So what we're going to talk about is how you secure DNS with DNSSEC. So first of all, let's go through a sort of a primer on how DNS works. So you have this resolver, and actually everybody who has a laptop has a resolver on it. And one of the things that this resolver knows is that, hey, I have this name and I need to get the IP address for it. And what it needs to know about is it sends a question to a caching forwarder or a recursive name server. And this is set up by your IT department. And this is the guy that actually does the main this is the main workhorse to get you the information you need. So what the question is here is, hey, give me the IP address, which is the A record, for www.arin.net. So your resolver, which is on your local machine, which is probably being signaled by your browser saying, hey, I need the IP address here, so go ahead and tell me what to do. So this caching resolver says, hey, I just started up, I know nothing, and I need to bootstrap my information, and I need to go to the root server. And the root server, so the question is first asked to the root servers, hey, give me the IP address for www.arin.net. And the root server says, hey, I really don't know the answer to www.arin.net, but I do know where the .net servers are, and here's one of them. So the same question is asked by the caching forwarder, hey, GTLD server, can you give me the IP address for www.arin.net? The GTLD server says, hey, gosh, I really don't know, but I think that this name server, or I know that this name server will have more information with it. ns1.arin.net. Go ahead and ask for its information. So at that point, it asks ns1.arin.net, hey, give me the IP address for www.arin.net. The ARIN server says, yep, here it is. Here's 192.168.5.10. Goes back to the caching forwarder, which actually sends it to the resolver, and that information then is cached. So if that question is asked again in the next 5 minutes, that information is already known and it doesn't need to be asked again. So, and as you go through, your browser has many, many references to various websites on it. So this thing is really, really busy on the backside, finding out the IP addresses associated with the names. So does anyone have any questions about how DNS works? And this is how things work on a day-to-day basis. I'm seeing none. So we'll go ahead and go on to this. So what you see here is everything that's going on this particular page is done in the clear, and there's no security on it. So there are many, many vectors for attack that an attacker can do. And you as an end user have no way of knowing whether or not the IP addresses you got are correct. And you have no idea that if you're going to a bank, how do you know you're going to your bank? You might be going to an imposter's bank, because it's very easy for attackers to actually be a man in the middle in that particular attack. What DNSSEC does is that says, hey, look, as an end user, you can actually validate with these DNS extensions on it so that you can actually make sure that this information has come from ARIN and not anybody else. So it just ensures that the answer is correct and that it's coming from the right place. So therefore, you have confidence that you're going to your banking and getting your information. Or you're going to the Barbados government and you're getting your tax information correct and that sort of thing. Or anything confidential that the government may have on you that you don't want others to know about. So why is DNSSEC important? Standard DNS is not secure, it's trivial to spoof, really easy to spoof. And attackers can use that to redirect people going to www.arin.net to their own site, steal login information, personal information, everything else. So DNSSEC is surprisingly secure. So this information cannot be redirected in any sort of way. So cache poisoning is one of the vectors that they can use. And basically what you do is you give a incorrect response for www.net, ARIN.net, saying, hey, look, instead of 192.165. whatever, it can go to 192.168.5.5, and you know nothing better. And it can sit there for hours and days. So in fact, we've had a case study on this as the Kasparov attack, and I know about this personally because this attack affected me. I was at that point. As I was told you earlier, I've been involved in the internet since 1991. I was the guy who headed up this thing called the Internet, which actually at that point was a network information center for the entire internet. So any domain that ended in com, net, org, edu, gov, they all had to come to Network Solutions, and basically I ran that organization technically. And also all the regional registries that we know today, the 5 regional registries that we talked about yesterday, they were all under the Internet, of which back in by this point, both RIPE and APNIC were formed, but we were still, the Network Solutions was still running the regional registries for both Africa, LACNIC, or the Latin America, and also, of course, for ARIN today. And so ARIN was actually a fairly, Network Solutions was a fairly important place. It was highly known within the community at that point, and was also very controversial because until 1996, domain names were free. So if you wanted to get a domain name, you just came to Network Solutions, you got your domain name, it was free, and it was sponsored by the U.S. government. The U.S. government didn't like to actually subsidize this anymore since the internet was becoming a commercial sort of endeavor. And they said, hey, Network Solutions, you need to actually support this yourselves. U.S. government's no longer going to fund this. So we went out and said, okay, we're going to start charging for domain names. And at first, it was a fairly sort of cost prohibitive sort of venture. From our side, we had a lot of automation we had to do, and we figured it cost $50 per every year of service for a domain name because of vetting and everything else that we had to do. And various people in the internet community didn't like that. One of those people is a guy named Eugene Kasparov, who actually resided in Toronto, Canada. And he didn't like the internet's control, and he wanted to start his own service up, and it was called the Alternate. And in 1996, he used a DNS cache poisoning attack to change all our traffic, the internet traffic, to his own site. So when I came into work, I think it was on a Wednesday morning when this occurred, I got tons of complaints from people saying, okay, Mark, what did you do overnight? Because we don't have any traffic and we don't have any email that's coming into our systems. You must have broken something. And I was like, no, I don't think so. And I found people actually being, at that point, redirected, complaints being redirected to going to Eugene's Kasparov sites instead of ours. We then actually started using legal measures to get Eugene Kasparov to stop doing this redirection. And he was actually, we went to court. I remember going to a federal district courthouse and being a good person, I hadn't been gone to court before, and I had no idea what it was like. So for the first time, I thought there would be a wait. So I wanted to do some programming while I was waiting there. So I brought my laptop with me and my cell phone because I always needed my cell phone since I was on call all the time. And I went into the courthouse and they said, no electronics. So I had to go back to the car, get rid of all my electronics, come back to the courthouse and wait like everybody else. It's kind of boring sitting there without electronics. Not something I really liked at those times because I'm like, man, I'm wasting all this time waiting for this court case to come up. The court case right before us was a guy who was being convicted of murder, being put in prison for life. And at that point, I sort of snapped saying, oh, this is real life sort of scenario. This is pretty amazing, seeing this hard criminal starting to cry in front of the entire courthouse because he was being imprisoned for life. And the next court case was ours in putting a cease and desist order against Eugene Kasparov from doing this cache poisoning attack. So we got ahead and got our order for him to stop. He did, at that point, he did stop doing the cache poisoning attack. We then had a time for him to be deposed. where we actually sat down with him, with his legal counsel, with our legal counsel. It took place in Washington, D.C. He came to our legal counsel. He did not bring his lawyer with him. And we sat him down and we asked him all kinds of questions like, how did you do it? Why did you do it? That sort of thing. So I started asking him questions in terms of how did you do it? And he said, well, I asked people to start querying for my particular domain name. And for the response, I also poisoned the internet's IP addresses by sending it some additional information that I knew that name servers would cache. So when they would query for your information, it would be already cached in their name servers. I was like, okay, that's interesting. So when you did this, did you knowingly go after U.S. government institutions? And he goes, yep. Okay. Did you go after educational institutions? And he goes, yep. And then my last question was, did you knowingly go after U.S. military installations? And his answer was absolutely. So, the next day, mysteriously, there was a warrant out for his arrest for computer fraud. And at that point, he fled back to Canada. And then he had to serve some time in jail. And it was pretty amazing. So this particular attack could have been, there's a couple of lessons learned on this. One is, if you get in trouble, always bring your lawyer with you. Don't have him on the phone like Eugene did. Otherwise, he would have he would have probably stopped Eugene from answering me some of the questions that got him into trouble. Second thing is, if you're going to commit fraud, you are going to get caught in this regard. And Eugene did get caught. So that's all good. But the last thing is that this could have been prevented if DNSSEC was out there at that point in time. There's another case study, which is the Kaminsky study. And 2008, Jan Kaminsky discovered a fundamental flaw in the way that responses or transaction IDs are put out. Every time you ask a question, a response comes back that matches with a transaction ID. And it's very easy to guess because there's only 65,000 of those. And you can do this by a man-in-the-middle attack. This, again, can be thwarted through DNSSEC. So it's not only cache poisoning you can get things taken care of, but you also could have confusing results or malicious results coming back from a Kaminsky report, using the Kaminsky flaw to get back erroneous information. Finally, Bradesco is a bank in Brazil, and this is one that should scare you some. So there was a cache poisoning attack that resulted in a significant portion of their customers, even 1%, redirected to a fake site. So they had 1% of the users within Bradesco actually sending in their login credentials to a malicious site. And I'm not sure how much actual fraud was actually committed in this, but it was pretty significant. And this also made news. And again, this is something that DNSSEC would have helped solve. It would have thwarted this. So other uses, DNS is being used for other things. DKIM and SPF are anti-spam technologies that are being put out. If you're a mail provider, you know that spam is huge, and you spend a lot of time actually trying to thwart it. These are two additional technologies that could be used to help stop and mitigate spam. SSH, and anyone there actually use SSH. I hope that everybody does. So, and that's also used as a key exchange to make sure that you're going to the correct host that you wanted to. PGP key distribution for those who use PGP. It's a way of actually identifying users. DANE. So one of the things that's going on within IETF, which is a protocol standards body for the entire internet, is that they're using DNS as a global public key infrastructure. Right now, if you go to a website, you notice it identifies being secure by that padlock, saying that, hey, this is a secure website. And also allows you to identify that organization is organizationally or domain verified by a certificate authority. Now, I used to work for a certificate authority. I worked for VeriSign for about 7 years. And let me tell you, it's fairly easy to actually confuse these CAs to actually give you a erroneous certificate. And if you look in your browser, not only that, you can see that you have hundreds of CAs that all are treated equally within your browser, some of which are not as trustworthy as others. So in fact, it's always a good practice when you go to a website to make sure that the certificate authority that's issued that certificate is actually a trustworthy source. You may not want to trust someone that perhaps a certificate authority that is based in China. Or maybe you do. I don't know. I'm not sure I would. But anyways, DANE is a way to move away from certificate authorities because they're becoming less trustworthy and scalable over time, and to using DNS to actually do this work instead. So it's an exciting technology that's coming. To make that really powerful, you need to have DNSSEC. So you say, oh, this is great. Everybody should be using DNSSEC. Well, I wish that was true. So ARIN has over 5,000 members. And out of those 5,000 members, 139 are actually taking advantage of DNSSEC right now. And if you look at the number of delegations that we have 620,000 delegations possible within ARIN. And only out of those number of delegations, 671 are actually secured. So if you look at that percentage, it's less than a fraction of a percent. So it's actually a fairly small percent that is actually being secured today. You say, well, that's interesting because that's reverse. And yeah, this is reverse that ARIN's dealing with. But if you go to the forward zones, like using DNSSEC, because right now it's really kind of sad. We really got to start taking advantage of this technology because it will make our internet a better and safer place because it's full of bad guys. So how can we increase usage, identify barriers to adoption? Don't know how, don't have time, but I haven't been attacked. Maybe you have, but you just don't know. Then you need to knock them down, increase awareness like what we're doing now. Talk about education and that sort of thing, and trying to get through this all together. So using DNSSEC with ARIN is something that we offer. You have to go through a number of different things. You have to look at your vendor's implementation. If you run authoritative DNS, generating key pairs, creating these things called delegation signer records that you need to send to us, and you sign your zone. Delegation signer records are really important because they signal that your zone is secure. And these resolvers that I talked about way early, that are the workhorse of your DNS lookups, they use that as a marker to say whether or not your zone is actually secure. So these things are really important to have in your zones. So you have all these particular zones that you need to have secured. And what I'm talking about here is I'm not going to say, this is how you do it and this is how this works. But I'm hoping that you say, okay, I hear about these resource record types, and as I read about it, these are the important ones I need to know about. So you have DNS key, which is the key record is a public key for that particular DNS zone, and it uses asymmetric public key encryption to actually signature validation algorithms. So you need to have the public key available. There's the signatures themselves, which are called RR-SIGs, and SEC, which is a way of making sure you don't have a denial of service attack against non-existent records, and your DS records, which, as I mentioned earlier, indicates that your particular zone is secure. So we make only reverse DNSSEC available, but you also should make sure your forward zone, which is like CNN.com, FoxNews.com, you name it.com, or whatever, is done through your registrar. So How it works, DNSSEC adds new resource record zones into your zones. You then sign these things offline, and it creates two particular types of key pairs: zone signing keys and key signing keys. Zone signing keys change on a daily basis or weekly basis. The key signing key stays there for a long period of time, but it's not used very much, and it's used as a marker for the parent to know that, hey, this is a key that I need to show that my child zone is secured. This is what an unsigned zone looks like. For those who are DNS administrators, you can see this. Hey, this looks pretty familiar. Here you have a SOA and a bunch of name servers, a bunch of PTR records, which are used for reverse lookups. And excuse me. And this is what it looks like when it's signed. It has a lot of hex there. There's all these automated tools that do this for you. They create the signatures, they create the keys and everything else. So just gives you sort of a very much of a intro how these things actually would look like. So here are the new record types as a summary. DNS key, which is a key that's a public key that is both the signing key and the key signing key, which are used. The signature records, which are called RR-SIGs. The NSEC records that shows that you can cryptographically that you can't have you can't deny away non-existent zones. So what you can do here is you can say, hey, look, you asked for a non-existent name in my zone file, and I'm going to show you that prove to you that this name does not exist by this NSEC record, and it stops a particular type of attack to occur. And then there's the DS records, which are sent to the parent to indicate that the child zone is secure. So DNS is a tree hierarchy where the top is the root servers, and you've heard of root servers. And every part of the tree is a leaf node that comes off that root. And these DS records signal that the next branch of the tree is going to be secured. So how do you know it's working? You use the DNSSEC validating resolvers. There's popular options you can look at through the Internet Society or ISC. You can actually get a bunch of DNSSEC signed zone. If you want, after you get things secured, you can see a good visualization of this through DNSViz.net. And I sent you a URL so you can go ahead and check to see how it works. And so essentially the takeaways on using DNS, if you're not using DNSSEC, you're vulnerable to DNS cache poisoning, which means that your customers could be unknowingly to them being thwarted or shunted away to some malicious website. There's a lot of documentation available for you to actually use to take away. And what I'm hoping to say through this is that you can look at these things now and start looking at the key sort of indicators to go ahead and how you set up your zones to be secure, or ask the people that you are using to host your DNS to make sure that they have security put into place. So if you really want to do this as a user, and this goes into sort of cloud computing, you can use Google's public DNS for your resolver. So does anyone here use 8.8.8 or 8.8.4.4? All right, excellent, excellent. So you guys know that it's actually uses DNSSEC? It does. It's cloud computing, and it has DNSSEC turned on by default. So you as users can actually set your recursive resolvers to actually, you can point your resolver to point to Google, and you will get DNSSEC validation as a result. Thoughts about cloud computing in general. You may need to provide sensitive data to the sites. Cloud resources are ephemeral. IP addresses change from time to time. You have no idea if that IP address is going to be the same IP address later used for your particular VM that's associated with the site that you want to go to. The only way of actually having assurance is having DNSSEC there that's signed by the domain administrator of the site that you want to go to make sure that is correct. And if you didn't say, well, I had this IP address, how do you know that it was at that point in time actually associated with that site? The cloud computing organization does, but you don't. You would have to go through a lot of hoops to figure out, based on that point in time, to figure out who had that IP addresses to make sure that you're going to the particular site. From a content provider, given that's a shared system, how do you know you have the right connections? You have lots of data and payments that you have to deal with. How do you know that stuff is being done correctly? How do you know your MySQL database or your Postgres database, which has connections via IP addresses, is going to the right areas? And these cloud computing sites they have ephemeral IP addresses, so they change from time to time. How do you know that you're going to the right site? And then essentially, how do you know that your cloud provider is ensuring isolation between clients? So a DNSSEC gives you that sort of capability to make sure that these things are actually segmented properly and that you have some assurance that you're going to the right site. So as a result, I'm hoping that you got a little bit out of this in terms of, hey, this is interesting. I want to follow up more with DNSSEC. I need to learn more about these resource record types. I need to find out what RRSIGs are. I need to find out what DS records are, and so on and so forth. These things hopefully will be a little bit of a Kickstarter for you guys to actually start looking at this in detail. So it's a very high level, some thoughts to think about, some dangers of not doing so. So I open the floor now for any questions.
Thank you so much, Mark. I failed to say at the very beginning, Mark Kosters is the CTO of ARIN. And so as Carib Nuggets, we're very fortunate to be able to have presentations from different internet registries with us here. So what are your questions? Earlier at the Lightning presentation, Mr. King was saying how concerned he was with the data center. I hope at the end of this presentation, we are very concerned with what is happening in our internet space if we don't implement DNSSEC. So are there any questions for Mark? Andre is coming to the... Mark, can you just stop sharing your presentation so that we could get your full screen? Thanks.
Okay, Andre Griffith, Barbados ICT Professionals Association. Mark, very good presentation, very clear, very concise. What have of interest to me is pertaining to where you mentioned Google as a public DNS provider. I'm wondering if you also, you went into talking about cloud computing, other providers, using them to deal with your DNS issues. Have you ever heard about a company called StrongArm?
StrongArm? No, I have not.
Okay. Well, probably just one of those other companies that are on the market, but a lot of them are subscribing to DNS blacklists in a sense, and IP addresses that kind of like they will try to scan your DNS, and they would do like a recursive, the same form of the DNS set, trying to trace back where that address that the user at his or her desk is typing in that name. They're trying to trace back where that IP address is coming from and making sure that it's not belonging to a black hole. Like I think that one of the bigger networks is called, I think, Persistent. I may have the word wrong, but there are these huge black mailing lists, not mailing lists, but lists on the internet that tells people about bad DNS addresses, etc. I was just wondering, do you recommend that or do you see that as a trend for network operators to protect their users and their networks as they're going on the internet? Or do you have any insight in terms of these different subscribers? There's so many of them that usually it's good to go to someone who has a handle on it, because you as an end user don't have the time to know who's good or who's not.
Very good question here. Absolutely. So there's a number of there's two sides on DNS. There's you as an end user, which is one, and that's I'm going to answer on the question on your question. And the other one is those who provide DNS information. That's the authoritative side. So you have a website and you want to have your DNS information publicly available for other people, like users, to actually use. So let's sort of focus on the user side of it for a moment. So you as a user, you can use Google DNS, right? You can use another service. VeriSign also has a very similar service to what Google has. I'm using Google as an example because it's well known. Most people know about it. It has an easy to understand IP address associated with it, that sort of thing. So there's a bunch of other vendors that actually that if you have the ability to set the resolver in your machine to use a particular DNS recursive resolver provider, like Google DNS or VeriSign's DNS. There's another one called Dyn, for example. What they do, some of those vendors actually also have safety checks built in so that you won't be able to resolve sites that are known to be bad or known to have bad information or may have known virus providers or that sort of thing. So some of those, there's DNS providers that do provide those types of services beyond just DNSSEC that you can actually use. And those are useful. And some of those are maybe your particular IT administrator may use those to enhance their ability within their IT infrastructure as well. So there's a bunch of different things that you can do as an end user to help make yourself secure. On the flip side, on those who want to publish DNS information so that you can go to their website, there's a bunch of, again, publicly available services that will help sign your zones and make sure everything else is secure. For example, GoDaddy has one. So if you want to use them, that sort of thing. There's a bunch of others that actually can provide DNSSEC services for you. Google has an authoritative DNS service they call DNS Cloud, but it doesn't, as of yet, provide DNSSEC, but it will shortly. So there's a number of things that are starting to happen that you can utilize. You don't have to actually set this up yourself, but you can do this through some third-party provider if you wanted to. And again, this is just a high-level sort of overview on DNSSEC, what it secures, and what sort of information you would have to look for if you were to do this yourself. So hopefully that helps answer your question.
We have one more question for you, Mark, and that's from Jason. I don't know if we have any online questions. If not, we'll just have Jason as our last question.
Okay. Hi, Mark. Jason Hines, Internet Governance Caribbean. Thanks for the presentation. I think I wanted to follow up more on Andre's previous comment in terms of the people who are providing the listing of bad DNS and IPs. And I think that one of the points might be that when you consider a particular locale, like say Barbados, and someone has a credit union website or some small government site, I'm not sure if we can expect what might be the international U.S. or European-based list providers to have attack, to really capture an attack on that as quickly as that local community may need. So it doesn't negate the need for having at the country level and those DNS providers to employ DNSSEC.
You're absolutely right. A lot of times local is better, and the local environment is better than sort of global, sort of worldwide sort of users like Google. They just don't know sometimes. And you're absolutely right. Good point, Jason. Good point. It's good seeing you. Didn't I see you like a week ago? All right.
I think there may be a remote question. Richard?
We have a question online from Jonathan. Does level 3 resolvers 4.4.4.2 and 4.4.4.1 use DNSSEC also?
I'm not sure. I really don't know. Sorry.
Okay, thanks, Mark. I think this presentation, similar to Kevin's presentation, showed us that the adoption rate is really, really not taking off as we would have expected it to, in spite of the fact that there's a lot of education about this. And Mark, I just want to ask you, and the same thing I asked Kevin, are there any other initiatives besides education and training that are being followed to ensure this adoption takes place at a faster rate? Adoption of DNSSEC.
Yeah, there's this sort of general premise that security is hard, and it's only when things become real issues do people start awaken themselves and say, "Hey, I really need to deal with security," because and really I think what we will have happen is some large, wide scale attack will occur that will cause harm to many people. And at that point, these technologies will say, we got to have this and we got to have this now. And that sort of wide scale sort of attack has not occurred yet. But when it does, then I guess we'll have to, instead of being prepared, we'll just be victims and deal with it afterwards.
All right. Well, thank you, Mark. Thanks again for a good presentation. Let's give Mark a thank you. Great, and hopefully we'll see you soon, Mark, at next CaribNOG.
Yeah.
Okay, bye.
Thank you.
Okay, folks.